Hello, this video is about experiment 3, the maximum transfer and superposition. In this experiment, we're going to use Tinkercad to demonstrate this figure, this circuit. This circuit, there are two resistors that are connected in series and then connected with 10 volts power source. And in this experiment, we're going to measure V source, IL, VL, RC, and RL, and then we record it in this table. So let's get started in Tinkercad. So we need two resistors. Each of them is 100 ohms. And a battery as a source. Okay, once we have this, we're going to connect these two resistors in the power source. And we're going to measure V source, IL, and VL. As this one is 100 ohms and this one is 100 ohms. So we're gonna measure the rest. So we're gonna measure the source voltage. And the current is IL. So also VL. And this one should be black. And so now it's ready for the measurement, so we can start simulation. So when we start the simulation, here are the result of this experiment in where we follow this circuit. In this case, the voltage source here is 10 volts. So in Tinkercad, we have only 9 volts battery and also 1.5 volts battery. So we use 9 volts battery DC source as the source. And here is the result of this circuit part 1. So next part, we're gonna do this experiment, which we're gonna follow this figure 3.2. We have one resistor, a source, a DC source, and also potentiometer. And this table is to record the data when we train the resistance value here. So the voltage will change accordingly to RL. So let's see in Tinkercad this circuit. We have 1000 ohms. Yeah, basically 1 kilo ohms. And the potentiometer 5 kilo ohm. So this we connect to the positive. Should be red, this one. And also we have negative here. Like negative. Oh, should be black. Sorry. And this one positive. Should be red. And now we connect it into the source positive. And this one is should be here, connect. And this should be negative. It is black. So what do we want to measure here? We have 6 voltage source, but as again we use 9 we use 9 volt battery, and we want to know the VL accordingly to RL. So when RL change, VL would change. So we want to know this VL. So VL, we then need multimeter. So this one is done. So when we start simulation, this is result when we keep this constant. But when we train the variable resistance here, the VL, the voltage will change. Okay. Here when we change, the value of VL also change accordingly. So that's it for the experiment part 2, this part, and then we record output here. So the next circuit is about superposition. So superposition, this and this. Okay. In this circuit, in this figure 3.3, we have 3 resistors, 2 voltage source, and we want to measure the current I1, I2, and I3. So this table is to record the result. For example, when we open this switch, the current from this source will not flow. But when we close the switch here, the current from this source PS1 would flow to the circuit. So we want to see the current when we close the circuit. I1, I2, I3, how much would it flow to the circuit? And when we open this circuit and then we close this circuit, then we measure I1, I2, I3. So the current in the circuit will be different accordingly to the source, these two sources. So, okay, let's have a look in Tinkercad for this figure. So, we need a breadboard, battery, and 2 switches. And we need a resistor, 3 resistor. Mm. Mm-mm. Whoosh. Okay, then we connect this circuit. And this one is positive, and negative is here. Okay, so we don't know if we have done this process correctly. So in order to find out that the test current in this circuit, we can test it by using LED. So let's just try. This one is positive, and this one is negative. So the LED is bright, so which means there is current passed through in this circuit. And now we need a switch in this. So we need a switch, and we bring switch here. So it's on. When we click again, it's off. On, off. Okay, it works. And we need another battery. So let's say we don't want 9 volts because we need to have a different voltage source. Here. We might need 2 batteries of this one. Okay, 2 batteries. And this one. Let's see, wait. And then we need also a switch here in this circuit. So okay. So when we start simulation, it's still bright. On is when we off all the source. This one is off, on, and we on this also have the current here. Okay, so let's go back to the circuits. What we want to know is the current I1, I2, I3. I1, let's say this one is blue. This one is pink. Another, this one ampere. So we don't need this. Negative. Positive is here. Negative is here. also we need another multimeter measure I2. We don't need this line. It's really messy here, so let's say yellow. Okay, all is done now. So we start simulation. Uh-oh, something is wrong here because we did not turn on any switch here. So when we turn on the first switch, the 9-volt source, and keep this one open and close this one, then we would have this value in the circuit. This one is I1, I2, and I3. And if we turn off, if we turn on this one too, then the current is changed accordingly. So yes, this is the experimental result in, uh, in part 3, superposition. So yes, that's for the experimental result. When we turn on all this, when we close all the switch, the current to this is very small. That's why LED light is very dim. So when we close only 9-volt source and we open this switch, then we have a greater current flow in the circuit, as we can see from the LED light. So okay, it's lighter. So that's for the experiment part 3 of this experiment. So thank you very much and see you in the next video experiment.